are the team of Sergio, Ana, and Emilio, and we decided to do a model of Saturn as our final project. So here's how we made the whole project. First, we wanted to do a little elephant, and actually we turned that elephant as our first register project. We created a laying down elephant with functions in Desmos, and we had the intentions to 3D print it for the second and final register project. But sadly, we couldn't do it because by itself it wasn't. We couldn't get the revolution solid calculus because the functions we had in Desmos didn't work on Mathematica since they were on the x and y axis and not the x, y, and z axis as Mathematica works with. So then we decided to create a replica of the planet Saturn. The criteria we used to choose this figure was that it can actually be measured as a revolution solid because it's a round thing. If you revolve it around the x or the y axis, it can be done because it's a sphere and the rings attached to it. And it can actually, as I said, be measured as a revolution solid, and we could also enter the functions in Mathematica for it to be done, like the elephant that we planned to use before. And also those were the main conditions for us to do. First, to actually 3D print it and to create the formulas not only on Desmos, we tried many ways. First, we tried to do it with functions that revolved around the y-axis, so we could just grab an exponential function for the rings and a normal function for the circles. So it was just the y-axis, we created a circle, and we cut it in half, so it was just this, and we created the rings. We would just enter a certain domain and just enter the formulas in Mathematica, so it was a revolution solid. Then, when we entered the formulas in Mathematica, we realized that the outcome wasn't as we expected. It didn't look like a planet, it didn't look like Saturn, so we tried to do the same, but in the x-axis. So it was just a circle, cut in half, and do the rings. But it also didn't work. The outcome was not the same as the y-axis, but it also didn't look like a planet, didn't look like Saturn, so we tried another way in the end, and this was the formulas and the function that actually worked for our project. We worked with the cosine and sine functions, so the ring and the sphere could be created in Mathematica, and that was the way we actually achieved it. We as a team think that 3D printing is a really good technology advance because it can create replicas of what we as an individual wants, or as a big industry plan or investigation wants, without actually having to build it in a real size. This can help a lot in physics and mathematical studies too. It could also help in many ways in the medical area, like providing more exact and cheaper prostheses and stuff like that. And we also think it's a way of lowering the prueba and error thing.
Fused filament fabrication is a form of additive manufacturing. It's a process that a machine deposits a filament of a material, commonly thermoplastic, to make layers. The 3D printers add layers that are heated previously, and after adding more layers, the material fuses, forming a 3D object. This is the method we use to make our 3D model, and in base of this, we can notice that our 3D model is made by this method because has a distinctive lines in it.
When we want to calculate the volume of the product, we put in a recipient a type of water. Then, when put the solid, the product in this recipient with the water, and then if I want to calculate the volume, I only to delete the measure that is new with the other. When we print the product, we have a lot of errors in the solid of revolution. So when the final product have a lot of errors like this.